Okay, what we're going to look at today is relating some of these angle measures with the things that we know from special triangles and from right triangle trigonometry, okay, to be able to deal with angles of essentially any size, okay, any sign, positive or negative, etc. When we're dealing with angles, like we learned in geometry, there's an initial side and terminal side generally. Okay, the initial side is going to be where we're measuring from, and as we discussed on Friday, this is going to be the positive x-axis for us. Okay, when we measure angles. So when we have a positive angle or a negative angle, a couple of key points there. If we measure again from the positive x-axis and we go counterclockwise, okay, we consider that to be a positive angle. And if we go clockwise, we consider that to be a negative angle. Okay? So in our opener today, remember both of our angles we measured, we went down first. We had negative 5 or 4, negative 45 degrees. And then we also had negative 210, which put us back into the second quadrant. So key issue is making sure that we know when we have a positive angle, it's going to be clockwise from the positive x. And if it's a negative angle, it's going to be going to be clockwise from the positive x. Okay. All right. So we we only dealt with 30, 60, 90, and 45, 45, 90 on Friday, but today we're going to look at angles that could be bigger than that. Okay, like angles that might be 210 or that might be 475 degrees, something like that. Okay, and so what it boils down to is that when we're in the coordinate plane, if we have two angles, okay, that ultimately lie on the same spot, okay, we call those coterminal. Okay, they have the initial side being the positive x, and they also have the same terminal side. Okay, then we have what we call coterminal angles. So let's start with 45 degrees. If I were to draw a 45-degree angle on the coordinate plane, can we think of another angle that would be in the exact same spot as this? Okay. But going around in a circle, how many degrees would it be to go around in a circle? I go 45 plus what? Plus 360. So wouldn't it be 405? Okay. So 405 and 45 would be angles that would be coterminal. So if I told you to find the sine of 405, okay, if it's in the exact same position, shouldn't it be the same as 45? Absolutely. Okay, could we go the other way? Could I go 45 minus 360 and get a negative angle that would be coterminal with it? Certainly. We'd just be going around the circle the other way. So if I do 45 minus 360, it'd be negative 315 degrees. Okay, so all three of those angles are coterminal with each other. As a matter of fact, okay, would there be anything keeping me from going around the circle twice or 3 times or 100 times? Okay, so I could make this list of coterminal angles with each other, okay, infinitely long then, couldn't I? All right. So we did this one already, positive and negative. We did for 45. All right. Now let's do that same idea here with radian measure. Okay. We want a positive and a negative angle that are coterminal with pi over 6. Okay, so keep in mind if it's pi over 6. Okay. If we want another positive one, we could add, again, going around the circle. But when we're dealing with radian measure, okay, instead of 360 to add to this, okay, how far is it around the circle in radian measure?
2 pi.
Yeah, it's 2 pi. So if we go pi over 6 plus 2 pi, and of course we'd want to get a common denominator if we're going to add these two together. So we'd write it as 12 pi over 6, if you will, plus pi over 6, and that would give us 13 pi over 6. Okay. So that angle right there would be coterminal with pi over 6, and therefore all the trig values, sine, cosine, tangent, and so on, okay, would be the same for pi over 6 and 13 pi over 6 because they're in the exact same position on the coordinate plane. Okay. All right. We could also do the same thing with pi over 6 minus 2 pi. We could get a negative 1 by subtracting 2 pi, going the other way around the circle, and getting back to the same spot. And if I did that, I'd have pi over 6 minus 12 pi over 6, which would be negative 11 pi over 6. Oops, negative 11 pi over 6. And so that would be an angle that would be coterminal, okay, going in the clockwise direction, in the negative direction. Questions so far? All right. Okay. Next problem we're going to do here is we're going to be given directions that look like this. Let's say let theta be an acute angle in standard position whose terminal side contains the point 35, and we want to find the 6 trig functions of this theta. So keep in mind that if I were to draw a picture here, and the terminal side, keeping in mind the initial side is always going to be the positive x. Okay, if I have 3, 5 as my point that this terminal side goes through, okay, we want to name the 6 trig functions of that angle theta. And this work here is going to be very similar to what we did on Friday. We're going to find the sine of theta, cosine of theta, tangent of theta, and then of course we'll find the flips when we get that done. Keep in mind if that's the point 35 right there, okay, and I were to make a triangle situation out of this, that side would be 3 and that side would be 5. True? And we could do this anywhere on the coordinate plane. It doesn't have to be in the first quadrant here. We could do this anywhere and still find the 6 trig functions that belong to this situation where we have a 3 leg and a 5 leg. And if it's a 3 leg and a 5 leg, that's going to be 3 squared plus 5 squared, which would be 34. Square root of that would be our hypotenuse here in this problem. Okay. And once we have that triangle drawn, then the 6 trig functions should be a piece of cake. Right? Okay. So again, knowing that this is theta, that's going to be the angle in question. Again, initial side positive x, terminal side goes through 3, 5. So we're talking about this angle. So sine would be opposite over hypotenuse. So it would be 5 over radical 34. Which of course rationalizes to 5 radical 34 over 34. Okay. And the cosine is going to be 3 over radical 34, which again rationalizes to 3 radical 34 over 34. And the tangent here will be opposite over adjacent, so it will be 5 thirds. And then of course the other 3, secant, cosecant, cotangent, will all just be the flips of sine, cosine, and tangent. Okay. All right. So when we're given that set of directions, when we know that the terminal side goes through a particular point, okay, draw yourself a picture. Okay. Find the point on the coordinate plane, make a triangle out of it, label the sides that you know. We would take it to get to that point, 3 to the right, 5 up. Okay. And then from there, the angle that you have. And once you find your hypotenuse, you can find all 6 trig values. Alright. Alright, what I want to get to next is some more that we were doing with our work earlier today when we're asked to find values, sine, cosine, and tangent, etc. for angles that are not 30, 60, or 45. Okay? But that are actually related to 30, 60, or 45 as being multiples. Okay, so if I find sine of 210, okay, I can do the triangle work that we did in the warm-up here. Because if I go sine of 210, keep in mind that's going to be from the positive x, that's going to be 90, 180, and then 30 more. So my picture would look something like that, where that angle right there would be 30 degrees. And if that's 30 and that's 60, we know the relationship is 1, 2, and radical 3. And of course the negative right here, because it's going to the left. And we're also going down here, so if we're in the third quadrant, both of those legs would be negative. Fair enough? Okay. And so our question then is find the sine of that. Okay, keeping in mind that we're looking at this angle here. And if we do the sine of that, that's going to be negative 1 over 2. So the answer here should be negative 1/2. Okay, and of course we can check with the calculator. So let's do sine of 210. Actually, I got to change it back to degree mode first. If I go sine 210, I get negative 0.5, just like I expect. Okay. Now, what we're going to look at next then is there a way to do this without actually having to draw the triangle every time? Okay. And the answer is yes, and that's what I was talking about earlier about the circle. Okay. So this is what we call the unit circle. And this unit circle is going to help us find the trig values, sine, cosine, tangent, secant, cosecant, cotangent, for really any angle that we come across. Okay, and we're going to talk about this first, and then we're going to practice together by doing several examples. So there's a couple things that I want you to note here first about the circle. And the first part is that when we have angles around this unit circle, and keep in mind it's called the unit circle because it's got a radius of 1. Okay, so the radius 1 all the way around. And when we talk about it measuring from the positive x-axis, if we go in a clockwise or counterclockwise manner, the key angles that we know are 30, 45, and 60. Fair enough? Okay. And as we go around to 90, and then we go 30 more, we get 120, 30 more, 150, 30 more, 180. If we count by 30 degrees, okay, we can break that triangle up into special angles. And you'll notice that each of these angles, 120, 150, 210, 240, 30, 300, and back to 360, they're all divisible by 30. True? So they're all multiples of 30. That makes them special angles, just like 30 is a special angle. Okay? And keep in mind that with the position of the angles on the unit circle, okay, we know that the 30, the ones I'm going to underline, 30, 330, 210, and 150, okay, notice those are all closer to the x-axis than they are to the y, whereas the 60s, I'll double underline these ones. Okay, these angles are all closer to the y-axis than they are to the x-axis. True? So keeping that in mind, here's the deal with the sine and cosine, and then of course the tangent and everything else follows from sine and cosine. Okay, when we're at a 30, 150, 210, or 330, okay, all these angles, notice what their coordinates are like. Okay, they're all radical 3 over 2 and 1/2. The radical 3 over 2 for the x, and they're 1/2 for the y. Now, we know from special triangles, okay, that if I took the cosine of 30, okay, that would be radical 3 over 2. If I were to draw a special triangle here, it would be short side over here, long side over here. Hypotenuse here, it would be radical 3 over 2. Okay, until you notice that that number right there, that coordinate, is the cosine of 30 degrees. Okay, that is the cosine of 30 degrees. Okay, and notice this number is the sine of 30 degrees, isn't it? Okay, and here's what the deal is with the unit circle, and this is an important result. Okay, every point on the unit circle, okay, is of the form cosine theta, sine theta. Okay. So with that said, if you had this in front of you and I said, okay, well then tell me the cosine of 150. Okay, you should be able to look at this right now and say, oh, there it is, radical 3 over 2 negative. Fair enough? Okay, all you have to do is find the angle and then see what the x-coordinate is at that point. Okay, that right there is the cosine of 150. If I type that into my calculator right now, it would say negative 0.866, so on. Okay, so if I told you to find the sine of 300, we'd find 300. Here's 300, and the sine is the y-coordinate. So we would say the answer is negative radical 3 over 2, and we'd be done. Okay. We could do the same thing going with a negative angle. If I said do the sine of negative 120, negative 120, this would be negative 90, another 30, that would be in this position. Negative 120 would be the same as 240. Okay, and if I wanted the sine, I'd go down here and look and see, and what is the answer? Negative radical 3 over 2 again. Okay, so any angle that's related to 30, okay, we can find down here. And we can also do the same thing with 45. Okay, anytime it's 45, 135, 225, or 315, okay, then it's going to always be those two numbers that we talked about on Friday. Notice it's the third special number that I told you you'd have to have memorized, radical 2 over 2, radical 2 over 2. And the only thing different for those other ones that I mentioned is the signs. If we're in the second quadrant, it's going to have a negative x and a positive y. Third quadrant, both are negative. Fourth quadrant, positive x, negative y. Okay. All right, so let's take a look at a few examples.